This is the Access Lab 3, a little guide I'm going to make for you. I'm not sure how much we're going to do together and how much I leave for you. We'll see as we go. This is based on hardware lab from the Access Lab 2, so the hardware one. So I can tell you this much before I show you the Word document. Sorry, I had to pause and sneeze. Of course, there's always something. All right, it's based on this lab. Whatever you did in Lab 2, I think mine's in the state that yours should be at the end. There might have been a couple of things I said, I'm going to leave these for you to do, and I might not have done them. So we'll see how it shakes out when I do it. I think it should be okay to start. But for you guys, what you need to know is that whatever you turned in for Access Lab 2, you should have, here's the thing on Lab 2, if you read the directions, it says to turn in the actual lab, the database from Access, but also the Word document with the things filled in and the screenshots and all that. Most of you turned in the Word document. Some of you turned in only the lab, and I could judge from that if you did things right, more or less. Some of you did it correctly and did both, so good job. I don't know if I made it clear in the video, but in any case, you should have this Lab 2 somewhere. If you don't, you want to go ahead and recreate it real quick before you start Lab 3. I think especially if you don't have to paste screenshots and answer questions and stuff, then this should be fairly easy if you haven't done it. But ideally, you would have this saved somewhere. And for future reference, save all the stuff you do that you turn in this class in case you need to go back to it for some reason. I mean, that should kind of be intuitive, I think, for most of your classes. But I'll just make it explicit here. Save all your work that you turn in because we may or may not build on it later. Anyway. Go ahead and start it up. And I think what there might have been a couple more things, queries and stuff that you add down here that I didn't do, but I should have all the table data, and I think most of the work's there. We'll see. If it's not, I might have to pause and fix it and then continue. So no biggie. All right. So this is Access Lab 3, and for this semester that I'm making this video, I'm not sure if we're going to be using these videos the same in the future or revise them or whatever, but for the semester that I first make this video, this is the first semester I've taught the class where this part of I actually taught the second half of this class during the pandemic when it started. So this is the beginning part. I still haven't covered this outside of class yet. So and what I'm saying is that I've gone through this document like twice already and tweaked it a bit to make sure it makes sense for on campus and the links are still in date. There was one I had to remove here, but it's okay because you had a couple anyway for the thing that was teaching you. So as we go through it in this lab, and I'm not sure how much I'm going to do for you and how much I'm going to say, hey, you can finish it, whatever, we'll see, whatever I think. But regardless, if there's things that I pick up on the third time through that I need to tweak, I can do it now before I release it tomorrow. So this is Sunday night that I'm doing this, and that's why I'm trying to get this completely revised and back-loaded up in the corrected form before you guys even see it. So anyway, ideally you have two screens. I would normally have two screens, but I want to make sure everything's visible to you guys within this field. I could probably stretch it over two screens, but it might get weird for a video, so I'm not going to try it. So I'll have to be going back and forth between the open access database and the directions. So this is about modifying and creating tables, adding fields and field properties, tables, creating and using simple forms. So forms you want to use to enter data, usually the typical data entry helps guide the person who's entering or updating, I should say, data for your database. Forms make that easy. Probably something else I'm forgetting, but that's the main thing is data entry and data modification or updating. Creating queries that join to them or tables, so you get an introduction to joins, because I think in the last one we just did queries using the query, what is it called? Query analyzer, query builder, whatever, the wizardy thing. We learned how to do that with one table, but not really two. So we'll see how to do it with two. And then we learned a little bit about aggregate functions. So aggregate functions are a special kind of query. And we'll etymology, gregis means herd in Latin. So a grex is a herd of, like, I guess cow or whatever, cattle. Kine, if you want to get a really old term about cows. Gregis is the combining, like, form. It's the genitive singular. It means of the herd, gregis, and that's like how you do the ending. So aggregate has something to do with things being grouped together in a herd. So someone who's gregarious likes to be in a herd. You've heard that term describe somebody. Oh, that person's really gregarious. That means they like to be around other people. Egregious means literally outside of the herd. So something that's egregious is like beyond what's like normal and acceptable to the group kind of thing. And there's probably some other gregis word that we use all the time. What's the other one? I was going to say something about vaccines and herd immunity, especially during the pandemic, but I don't think the word gregis is used there at all. Anyway. All right, I actually looked it up. It looks like it's smaller animals, which is as big as sheep, but like, what is it called down here? A pecus is the word for like cow and stuff that pull draft animals and stuff. But whatever, you get the idea. I like etymology. I can't help it. I think you should too. And if you don't, I'm playing Twilight and Tabletop Simulator. I'm doing ASDF to navigate instead of doing scroll up and down. Anyway. So let's go through these. So that's the skills you need to learn. And then here's some tutorials, which means that you don't necessarily need me. Ideally, you would take this. I would actually encourage you to stop right now, watch these videos maybe, do the lab on your own or attempt it. And then if you get stuck, come back here. Or even if you get done, before you take the quiz even, come back and watch the video and make sure you did it all right and that kind of thing. But so my recommendation is to pause and do it yourself. That's the best way to learn. People hear about learning styles. There's a little bit of preference among people, but for the most part, it's kind of a BS topic. Actually, learning styles are kind of a myth. There's been lots of research done about it, and there's not a lot of evidence that people have distinct, like, oh, I learn by watching and I learn from hearing, and mostly people learn from doing the best everybody does, and then maybe seeing and then reading. I don't know. There's different ways, but it's kind of a myth that they're learning styles. So I won't argue with you about it. You can disbelieve me if you want. You can go read the research, but the long and short of what I'm trying to get at is that if you do this on your own, actually do the lab and follow the instructions and do the things in it, then you'll learn better than like listening to me and looking at me showing you how to do it. But that being said, there's no shame if you get stuck to say, hey, how do I do this next part? It's in the video and come in and looking. So that's how I would tackle it in your shoes. Unless, I left it till the last minute and I was pressed for time, then I know and I'm not saying I've never done that, so whatever. So whenever it says H drive, I added personal machine here. I didn't really know how to express this. So your C drive, on your at-home computer, that's what I mean. You could use an external removable drive too. Originally, this was all about doing it in our lab. So we have a network drive that you would have your stuff on no matter which machine you sat down at. You would have your stuff on that network drive and you're in your space on the network, right? But you could have also just opted to put it on a thumb drive and take it home with you and work on it and then bring it back or whatever. But now you could even all of us are going to probably just be doing our work on our computer. So your C drive in this case, in which case, if you noticed, I have a directory set aside for this class. Here's the Lab 2 directory. So probably at this point, actually, I want to go up a directory and create a new one. Let's do it up here, called Lab 3. And as a matter of fact, whether you copy the one from Lab 2 here and then open it, or in this case, I think what I'm going to do is go to here. Actually, you know what? I'm going to do this. I'm going to close it. I don't want to do the save as. I'm going to actually go down here and open this up. pick this hardware lab. This is the one I actually worked on, right? Copy it, Control C, and then go to lab 3 and paste it here, and then open this and work on it from here. All right. I'm about to start following the directions, but I know this is one of them, and you pretty much have to do enable content to make sure you can start working on it and actually do things. All right, open relational database for your name and you created in previous lab. Choose file, save as, save new copy of the substitute lab 3 for lab 2. So I didn't actually do that part, and I'll do that right now. I'm going to do file, save as, save database as, blah, 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 blah. This is what I did. I don't want you like looking all in my directories. That's what I tried to avoid, and I can't seem to do it. So just save here. Except no, I don't want to replace. I'll make this 3. God, sorry, I'm kind of distracted by that whole. I need a computer that just has school stuff on it. So I have to do double duty. I should go like grab my computer from my office and say I'm taking it home. Some of the instructors did that. The professors did that at the beginning of the pandemic, and I'm like, I don't want to bother. I got a computer at home, but whatever. All right. Okay, so I deleted the old hardware tracker 2 because it's still in lab 2, and I don't need both, right? So that's deleted. And if you look at 3, this is open. While it's open, you have this like log file for the database, and some people, there was somebody, maybe a couple people don't turn this in unless it tells you to in the instructions. See, it's only 1 kilobyte. This is the one you want to turn in, the one that's ACCDB. You're going to turn in a back. At the end of this lab, you turn in a backup copy, and I think that might have a different ending, but extension, but it will tell you what it is by the end of the lab. So this is the one. This is the lab I'm working on, and let's go to the next. Get rid of Gregus down here. Belabor that point. Okay, so typically compose more. So again, this is stuff that you already know, and we're going to add 2 new tables to our database and modify some of the existing ones apparently. So in our object browser, locate the hardware table. I don't know if this is this is kind of a general .NET Windowsy Officey thing that you kind of put a 3-letter prefix on the beginning of something when you name it, so you know what kind of thing it is. So this is called TBL hardware to show that it's a hardware table. I don't like this scheme. I like in a regular database, you would just call it hardware maybe, but whatever. That's why I'm just explaining why that's there. That's just telling you that this thing right here called hardware is a table. If you completed Access Lab 2, you should now have at least 22 records in your table. So let's do this. Let's look. Hardware table. Still right here. At least 22. I don't have 22. Why don't I have 22? Dang it. I feel like we added some piece of hardware. So I'm going to pause and see what we added. Okay, this is the part I kind of hand-waved at you last time in the video. I'm like, hey, you can do this part. So of course, I didn't do it. I don't know if there's a copy of this that I finished, which I have. I don't know where it is. So here's my information. So I went to my control panel. If you go to System, it gives me some info. So this is a 10-year-old computer. No, it's older than that, probably 11 at least. At the time, this was a good processor. I built this computer myself, the one I'm on right now. No, wait, hold on. No, this is my laptop. Never mind. Forget what I just said. This is an old computer I got from my work school. So, I mean, it was okay for its time, too. But I had an i7 860, I think, in my desktop. But this is my laptop that I got from an old job. So, it's time to update, probably. But this is what I've got. This is step 8. So, I didn't do step 8. Step 8B is look up data about your PC in class or home laptop or desktop machine. Or you just make up stuff. Paste the screenshot here showing proof that you completed this step. Look up the data about your PC and add it to the hardware. Yeah, I know. I had to add it to the hardware table at some point. So anyway, and I had to look up how to do this. Yes, it's been a while. I'm like, where is that system info? Let me look it up. Anyway, so we're going to add a piece of hardware, and I forget where this has already auto increment identity kind of thing. So I'm just going to manually type in 22 for the next piece of hardware. If I want to really go by this, I can look up and see how many gigahertz it is. It looks like it's 2.6 gigahertz. So 2.6. And again, if I were designing this database, you would not type GHZ there. You would just know that this column is you would know that it's in terms of gigahertz. It's ridiculous that you would type GHZ for each one of those, but that's how this one's set up. So we're going to do it 2.6. Yeah. And what is it? It's an Intel, right? Intel Core. I do want to move the projector, whatever. Intel Core i5 is good enough, honestly. We don't have to put all the other stuff in there. And then serial number, I don't know where the serial number is. I'm going to make one up if I can find it. Does it have it here somewhere? Serial, oh, there's product ID. Let's use that. See if it'll fit. Oh, I can't. So you know what? I'm just going to make stuff up. Again, this stuff's not important. The important thing is that you understand. You can see how data are input into a table and that kind of thing. As far as having the right specs from your computer, it's just sample data. It's just meant to give you experience, sort of like, you know, like, oh, this is sort of real world, not really, but this is good enough. The product ID, by the way, is, oh shoot, product ID. God. I'm wondering if that will get me in trouble. Can you use that to do stuff? I don't know. All right, I went and checked. It looks like it's not a big deal for people to know this. If it is, you know what? Knock yourselves out. I'm not gonna deal with it. So whatever. So yeah, and the next, what is it? RAM. How much RAM do I have in this thing? I probably need more. 8 gigabyte. It's wimpy compared to some of these. Oh, I put that in the hard. That's the hard drive size. Sorry. Actually, so the RAM's pretty good compared to. And honestly, leaving that as 8 gigabytes, who cares? But I think I've got 400, 200. How much do I have? I'm going to pause you again. I took the liberty of when I got to keep this computer after I left my job. So, and at some point I took the liberty of, I think, doubling the hard drive space, but also making an SSD. So I think it was like 250 or something before. Now it's 464 gigabytes. Is that right? 454, 464. Whichever's fine. You know, just like 400-ish is fine. 464 gigabytes. I mean, I don't even know why I care about making sure it's right, but for the sake of argument, that's what it did ask us to do. What kind of computer is this, actually? Is this a Dell? I think this is a Dell Inspiron. So I'm going to put Inspiron here, even if it isn't. It might even say it on the system stuff over here. I didn't notice. But whatever. This is a laptop that I'm using. And it's assigned to me, and I should be in the employee table. I think I added myself, but in case I didn't, here's the thing. You can't add somebody who doesn't exist. Remember, this is, yeah. I'm glad I could click away and look. Referential integrity. I don't know if it's actually 022 or just 22. We'll see. Why the things I think I'm typing are not what I'm typing. All right, so it's not going to accept that if it's not actually a reference to somebody in the database, and obviously it is, and it's probably me, right? So looks like we did that. So we're good. We're up to date. So let's go back and look and see what the next step is. And I'm going to keep Access Lab 2 here so I can refer back to if I need to. So some of you might need to do this if you haven't. Open the hardware table in design view and examine the fields. Make up each record of the table. Notice there's a category column defined to be short text. To minimize data entry errors, we always want to allow users to choose text using lists or buttons rather than allowing them to type freeform text. So we're going to change the data type of the category column from short text to lookup wizard. So let's do that now. Category, and hold on, I have to remember how to do this. I miss things because I'm reading and it just goes one in through my eyes and out through my mouth, and I don't even think about it because I'm talking to you guys. But we want to do this in design view. So right click and pick design view on the hardware table, and you see how it says short text here. Let's make this bigger. So it's the type or the category of the computer, but we don't want it to be short text. We want it to be, if you click here, you have a drop down. This is kind of meta, right? Because this is ultimately what we're going to do for the hardware table, to make it to where when the end user is typing in data, he doesn't have a choice about what he types, like an infinite choice. He has to pick among a set list of selections, possible thing. So lookup wizard is what we're going to pick here, and it's going to start a wizard. Now we have to see how this wizard operates, and it's going to be awkward because we have to go back and forth. So we'll see. In the properties window at the bottom, choose lookup tab. So from short text to lookup wizard. In the properties window at the bottom I'm assuming the wizard will choose the lookup tab. So let's see. I don't see what they're talking about, so let me pause and find it. Okay, honestly, this seems a little different from the directions. So if you do look up down here, you get a thing that, but let's ignore that for now. Let's pick the wizard, and it ultimately does the same thing. So we're not going to, for this one, ideally this is how you would do it, in my opinion. You would have what we call a lookup table. So it would be a whole other entity of categories in the database, and you would select what, it would be a foreign key here. In other words, you would have primary keys of categories in the other table, and you would put a foreign key here that would tell you which category. And whenever you add a new category to the database, you would add to the category table, and then you would add a hardware maybe, and then pick that foreign key from that table to be here. That's the way it should be. Access is a little kludgy in my opinion on this. What you can do is something, it's more like what you would call a constraint. You would list the domain of possible values for this field here, and it would sort of do the same thing as the category table lookup thing would do, except not with another table. I think that's what these directions are going towards. So we would pick, I will type in the values I want and click next. And then the number of columns, I don't know why, let's see, values, you lookup field, enter the number of columns you want in the list. And I think we just want one column. So we're just gonna do one column, and then we would type in the values to this. Let's see if this is how it works. Could have sworn, I don't remember this part honestly, but and this is where two screens are really helpful. This is the other lab. This is the actual access, and of course it's a modal window, so I can't move I can't shrink this, so I have to like do this. It's probably ideal. No, it isn't, because as soon as I click here, what happens? That's what happens. Hold on. So I canceled the wizard, resized. And before I start the wizard again, now I can, okay. That's bad UI design in my opinion, but whatever. So we're going to do this one where we type a list, and let's make sure this works correctly. So cell phone, I would call it smartphone these days. Cell phone's kind of an old term, honestly. Oh, damn it. Let's go back. I swear to God. Most people say just phone, really, but if they do say something longer, they usually say smartphone, don't they? I don't know. What do you guys think? That's what I've noticed. The trend is away from cell phone to smartphone, because everyone's cell phone is a smartphone these days. I'm sure there are some exceptions, but they're few and far between. So it looks like these are the list of things that I've got. It's still called category. Let's limit to the list for now. If that needs to change, we'll see later. All right, look up. Combo box is what I want here. Okay, let's see if this is right. You can just save, exit that. That's what I did. I did it off camera because I don't want to make you guys suffer through having to deal with it. So exit out. If you're still at the same place I was a second ago, you just kind of, whatever it is, to close it and say yes when you save. It asks you to save, and then double click on the hardware table. That brings you back to the data sheet view, And you just want to verify this, that when you go through these different values and you get to the category, that you have a combo box here, a drop down list, and you can switch among these. Now it's supposed to stay the same as what it was before, so I think that was laptop. I'm not going to worry about it if I change one, but whatever. So I use these. You can add, again, you can add some more if you think it's reasonable. I'm not going to add anything. So this is the part that I just did that was sort of off camera. This is the part we did really just do. And this, we made sure that our drop down list has the values in the category column. All right, so that's that one step down. So let's add the following 3 columns to the table hardware. So columns, what they're saying is we're going to add 3 fields to the entity, 3 attributes to the entity. These are 3 more things that will compose. The tuple will comprise these 3 things. These 3 things will compose the tuple. So the combination of all these things will define a record for a particular piece of hardware in the database. So we're going to add, and again, I'm repeating these things because they're like terms you want to make sure you understand when you get out of the class, frankly. I mean, that's the whole point of the class, right? But also like on the tests and stuff, you want to know tuple, hardware, what an attribute is supposed to, and what its relationship to a column is, which is a column kind of represents an attribute, right? Or a field's sort of a synonym for attribute. Field's what you call it in the actual table. You have a field for each attribute of the entity. It depends on whether you're going back and forth between like the logical model and the actual implementation, what you kind of call these things. And even then you can sort of use them interchangeably. I want to say most people would say field when you're actually working in the database, but whatever. All right, so current value. Okay, see, there's the columns we're adding something called current value, which is a data type of currency. So stop right there. Just remember those 2 things. If you're like me, you're still somewhat capable of remembering 2 things in your short-term memory. Am I? Yeah, I think. So I think the easiest way to do that is to go here and click add, then pick currency. That's the data type, and then name it. So current value. And now you see it's sort of in that mode now that we're adding columns, so it sort of expects that we'll do it. That's the predictive view of the user. What would the user expect to happen next at this point in interacting with the interface? Well, they're entering the name of a column. They probably expect that you would be able to enter another column name after that. So we're going to make it to where they can do that. That's sort of what that view of the user is. This is not something you need to know for database, but it's just talking about interface design. So OPSYS is the next one, and it's going to be a lookup wizard with these choices. And it represents the current operating system that's installed on the computer. Honestly, I think that should be handled differently in a database, but we're fine with it. Using the wizard, don't limit entries to the choice. So I think it's saying that we should make it to whoever's entering this can add new categories, maybe. We'll deal with that when we get to it. So the way we do that, I had to pause there. So the way we do that is, what is this one again? OPSYS and lookup. So let's click to add a lookup. Lookup, and I don't want lookup in relationship. I just want lookup table. So we need that wizard. Maybe pick short text, I guess, and OPSYS. Again, I am not an access wizard, so I'm just going to like see what makes the most sense. So to me, the lookup and relationships suggesting that you would try to do the thing about with the other table that I was talking about earlier, which I kind of prefer, honestly, but that would involve more design and implementation than we're actually doing. It would be not following the directions too. So let's go ahead and do it this way. So this would be, I started with not here. So if I go to design view and do a lookup wizard from here, I'll make it to where I will type in the values that I want, and I will type in, here they are. So this is how the other thing was actually when I first started. When I say the other thing, I mean there's another question that has choices. That was the one we just did. And I changed it to this. I don't know if you prefer this. I do. I prefer a bulleted list of things like this because I hate losing track of where am at. Mac OS 10, 10.6, Snow Leopard. Okay. And I don't know why there's, oh, I was going to say, I don't know why there's a parenthesis there. It's because it starts right here. With colon, these choices. I'm not sure what to do with this thing because it's not part of the... You didn't sign up for this part, did you? Watching me try to... I'm not a word person. I'm not an expert at this stuff. Really, honestly, this should go here. I want to pause and fix this. All right, I hope this makes sense. So, OPSIS data type lookup. Okay, OPSIS dash data type current. Let's put in parentheses. Here we go. Lookup wizard. Which, yeah, technically we would do this, which to follow the pattern of the other answer. So data type, lookup wizard, which represents currently installed operating system. Feel free to add, especially as it relates to new hardware. Your table use these OSs. So it used to say don't limit or don't limit it. I don't care if you just have these four. That's fine. I'm gonna make it easier on both of us. So let's do just these four. So I think I'm at that point right now, aren't I? Yeah. So I'm going to do Windows 7. I'm trying to think why you would have two columns here even, which makes it confusing. But there's probably a use case that it's not just popping up in my mind. I'm not going to put Linux 4.15 because like 13 or whatever. I mean, they're talking about the current kernel. Who knows what it is now, and I don't think that's that important. You maybe add that as a subcategory. I'm just going to say Mac OS X too, so OS 10. Don't worry about the Snow Leopard BS and stuff. That's probably way out of date anyway. So this is good enough for me. Click Finish, and then when you go, it says combo box already in the lookup. That's what we want. So I think that should be fine. If you double click, you can save it. If you double click here and check it, you should see that the OPSIS does have choices you can pick. And the last thing is an image, which is a type of attachment. So it's called image. So we will add it's way at the end here. Now this is too small. Attachment is what you pick right here, and it's going to look like that. It's going to look really weird, and I'm trying to remember how to change the name. It always does when you do this, and it does that with the name, and you want to make it image. You can change it. It's just, but it doesn't prepare you. What I'm trying to say is when you do this, it doesn't prepare you for the fact that it looks weird at first, but it is fixable. Let's see if I remember. If I don't remember how off the top of my head, here it is. You can just go to design view and type image here and you're fine. Make sure that still says attachment though. And then close all this to make it force it to save. And then double click on hardware just to check it. And it should, again, it's too small now. See now still, there's a way. What is up with that? Let me check. Okay, I changed it down here where it says caption under general as well, and that seems to work. I don't know. It's a mystery. I hate things like this and stuff like access. There's so much garbage that you don't know why things are the way they are. But anyway, it says image now. And so we're fine. We're fine. This is fine. So I get, I'd much rather this be SQL. Oracle or something, not Access, but whatever. So I sympathize with you, is what I'm trying to say. It's not so bad, though. A lot of things are really easy in Access. It's just like there's inscrutable interface design reasons. I don't understand them, but whatever. So now let's add data to the new columns in your hardware table. I'm sure there's some reason, right? Like that I'm not aware of, but here's the thing. This is coming from somebody who Georged. What does that even mean? Judged, I think that's what I was going to try to say. Or graded, evaluated, graduate level assignments in human-computer interaction for like 6 semesters at Georgia Tech. So these weren't morons I was grading. So anyway, what I'm trying to say is that one of the principles of interface design, human-computer interaction, is if the user makes a mistake, it's the designer's fault. Because the whole point of making a user interface is, in any kind of interface, not just human-computer interaction kind of focuses on these kinds of interfaces and other ones related, but just in the real world, even interfaces. Like there's a famous example called the Norman door. It's based on a guy named Don Norman who wrote a book that I recommend everyone should read this. It really enlightens things for you about the world around you. It's called the Design of Everyday Things. There's a certain door called a Norman door, and it's because it has a thing on it. These are the doors where it looks like you should push them, but you actually pull them because of the thing that's on it. It's called an affordance. An affordance is an aspect of an object that allows you to apply some kind of action to it. And you can build affordances so that they suggest what action should be taken. So if, for example, if it's a door that has like one of those round like tube handles, that implies that you grab it and pull. That's the affordance. It allows you to grab, right? And it also allows you to pull. Sometimes the door's designed the hinges wise to push though, and that's what's called a Norman door, because it implies, the design implies that you do something that's sort of the opposite of what you should do. But the long and short of what I'm trying to get at there is a big tangent, but I think it's worthwhile to talk about stuff like this, is that, and this is me, it's kind of a cop-out, because I'm like, why do I not know how to do that? And I remember this being a problem from the last time I did it, and I forgot the solution or the reason, or if there is one. I should not, as a user of this interface, be put in that place, because it violates, for one thing, the principle of consistency. If I named all those other columns that way, and in other applications that are like this one, in the office world, you name the columns in a certain way, and then all of a sudden doesn't work that way, that's not the principle of consistency. So even if there is some like technical reason for why it should do that, you should still give the appearance to the interface user of consistency, regardless of your rationale for how you do things. So that whole little paperclip thing that comes up instead of like the title like every other column was, it's just poor design. Whoever designed it was not a good designer. So that's my opinion on it. Getting back on track. Maybe. I can never make a video where we're on track the whole time. But it's the same if you were on campus in class. The rants would be even more off the hook. So 3 pieces of software. Oh wait, this is the other this is the other lab, which is stuff that I hadn't done. I hope it doesn't bite us in the butt yet. But you guys should have already done it. Okay, for OpSys operating system, for the OpSys column, set all of the AMD 7th generation. So we want all of the AMC 7th generation systems to be Windows 7, and then everything that's not AMD 7th generation to be Windows 10. All right. Okay, here's how you cheat. And I think I've got this down. It's really bad interface design again on Access's part. Now, this could get kind of hairy, so if you're more comfortable, it's just tedious, but it's easily done and maybe faster because I have to teach you how to do it. You don't already know how to do it. So it's probably faster just to go and do the drop-down boxes individually. So Windows 10 here, Windows 7 there, etc., etc. If you do want to attempt this is what you do. You go to Create, and then you pick Query Design. Open up a query window, and this is what you type. And if I go to SQL View, there we go. if I don't mess this up, it's very small text. I don't know how to make it bigger off the top of my head. I'm sure there's a way, and I'm sure some of you could tell me how to do it. I don't care. It should be obvious to me. And again, interface design, if it's not obvious, then it's wrong. But anyway, there should be like, settings or font or whatever. I don't want to hunt it down. So, and I do not choose to use Access most of the time if I want to do database stuff. So I don't feel guilty about this at all. Anyway, update tape. I want to take this stuff out when I redesign this class. Update table hardware. That's the name of the table. Set OPSYS, OPSYS equal to, and double quotes seems to work, equals, set it equal to Windows 7 in this case, where the P type, the processor type, and again, the case doesn't really matter there, uppercase, lowercase, but where it's equal to, and this is, we could use like here, and like has not been working for me correctly, so there's probably a trick to it, I don't know. So instead of using like, and you'll know what I mean by that later, I'm just going to use equals. The thing is, all of these are the exact same. These 7th generation AMD have the same exact text in every field. So for this particular data, in any case, I can depend on it. If you notice, I've already done this. So just to pretend that, you know what, as a matter of fact, no, I won't do it. Never mind. I was going to clear them out, but I'm not going to do that. So what I did is I copied this exact text. You want it to be sure it's exact if you do this. If you're doing this, make sure you get the exact characters here. Don't get any extra spaces or anything. And I feel like I didn't get the A, but we'll see. Okay, I did get it. In double quotes. And then what you want to do, to me, the easiest thing to do is just exit. Click at the X, it'll say, yes, I want to save the changes to query 1. I'm just going to leave it as the name query 1 because this is just a little quick thing we're doing. And then once you've got this here, double click and it says, are you sure you want to run this type of action query? Yes, I am. And then, yeah, I know I can't undo it. So there we go. And I click yes, and it changes all these to Windows 7. If you haven't done this already, like I have, you would see that it would change to Windows 7. Just to verify that, I'm going to open this up and see, why can I not open it in just SQL View? Oh, it's already in SQL View. Okay. Let's just pretend it's like we want to do it to Windows 8 instead, just so I can show you. So I'm going to save this query, and then I'm going to run it. It's not what I wanted to happen. Oh, I don't know what that is. Let's double click it here. That's not it. I swear to God. Exit this. Double click. Yes. I don't know what it was doing just now, but whatever. If I go back to the hardware, you should see it says Windows 8 and all those. So I'm going to put it back the way it was. For some reason, that needs to be closed. It's stupid. Oh, wait. Hold on. I'm going to open this in Design View. Go here. Change this to 7 like it should be. Save it. And for me, it's just exit out of it. There's probably a way to run it from here. I don't know what it is because I tried it like 5 times and it didn't work. So run it here and then open up and see it's Windows 7 again. So what I'm going to do now I don't want to run it. I actually want to open it in Design View. And while I need to change all the other ones to Windows 10. So how I do that? Use does not equal here. And apparently it uses the old basic version of do not equal, which is it's either less than or greater than. Less than symbol followed by greater than symbol. That means does not equal. Instead of using exclamation equal like everything else does these days. But in old basic, that's how you would do it. So maybe that's the point. I think this is correct now. Let me see. I did run it once before. So you double click yes, yes, and those should all be Windows 10. Let's just double check by making this. Oh, it says Windows 7, so it didn't work because this should be changed to Windows 10. Sorry, before you run this, let me exit. Is it not actually working? Let's see. Oh no, everything's Windows 7 now. That's right. So it did work correctly. So I'm going to double click on this again now that it's been changed to Windows 10 properly, and then open up your hardware, and then you should see that everything is Windows 10 that's Intel, and everything that's AMD is Windows 7. That's like a quick cheat to it. So if you didn't do it that way, again, if that was confusing at all, I recommend just doing it by hand when, you know, this, in other words, like this one needs to be Windows 10 and this one needs to be Windows, you know, one at a time. It's just annoying to ever have to do that when you know there's a better way. And that's why I had to do it. That's why I had to show you how to do the update in SQL. That's a preview of stuff. A preview of stuff in the future is redundant. So it's a preview of things that you can do in with SQL. This is much better than like using Access to do stuff. Is this lab 2? Yeah. So where are we at? We got a lot to go, don't we? I swear. All right, so the image thing, we did that. Oh, yeah, we did the add one image to your table of the new piece of hardware that you added for item number 22. Leave the other ones blank for now. So I don't have anything on hand. I don't have a picture of my computer. Let me take a picture. All right, so I took a picture. You can see all the dust. This laptop screen's off so that I'm only looking at this old LCD screen on one screen, so I get the same effect for the video. So I turn this off. It's distracting when it's on. Here's an old iPad with a Bitcoin ticker. It's currently at 46,008. It's down from being almost to 50,000 today, but whatever. There's the what do you call it? Pop filter for my mic that's in front of my face. Here's the arm for the mic. So I use this mic in front of my face while I record for you. Here's my new web camera up there. Anyway, this is my computer. So I've got that. I want to save. I already saved it as my computer in my stuff. So let's add this image for my computer. It's this one that I added here, right? So what you do is click here somehow, and then double click. There you go. Double click. When in doubt, double click. Then add. Then you're going to do a search for the file. It's in my downloads, and it's my computer. This is stuff from where I graded people. I'm sorry to like somewhat dox people there, but it's not. Anyway, so I added that picture. Later on, we might have a way to. There's a way to display it if you double click. You know, open. There we go. You can look at the picture there from the data. This is from the database, not from Google Photos. That's because I saved it to Access. So there you go. And of course, when you like actually create some front end for this database, you could have a way of displaying all the pictures if you wanted. All right. So yes, you can save an image or a file, binary file, as data, as a data value at the intersection of a record or a row and a column. In this case, this is the record of my computer, the image attribute of my computer. All right, where are we at? Is this still 2? Of course it's still 2. I should just hide this because I keep clicking on it. This is 1. Okay. So we up to here, I think. Had the appropriate operating system, second row. Yeah, it's Windows 10 anyway. I think I have that. Now add one new column to your software table called vendor site using the data type hyperlink. Let's just go ahead and do that. So software table, add a column. Click to add. Data type hyperlink. There you go. And then we call this vendor, and I think it was all one word, site, like that. And then we're probably going to add the site of like our computer company or something, whoever built our computer. So let's see what they ask us to do. Add your own internet links as data for each piece of software. Not your laptop. This is software. Yeah. So each piece of software by looking them up with your favorite search engine. I will let you do this one for sure. So, but all you do is like, you know, look up what's the software we got here in our. So SQL Developer by Oracle. Well, I'll do one. So SQL Developer. Here it is. That works for me. You might want to download this. By the way, create an account on SQL and download this for later, because before the end of the semester, we'll do something with SQL Developer. I'm not sure exactly what yet, but we've done stuff in the past. So you do this, you know, and so on. for the rest of these, whatever you've got in your software. All right, so create a new table. Okay, so add your own error link. We already did that. So create a new table named security using the table design tool. It will have a primary key named role, for example, technician, user, coder, DBA, manager, and a privilege column, for example, queries run, all, query add, forms run, reports run. So just to, translate that, saying the person with this role can run queries. The person with this role can do everything like the admin, right? All. For this person can create a new query. This person can run a form. This person can run a report. And honestly, there should be a many-to-many relationship between, except for all, of course. Some people could probably do like these two or maybe these two, whatever. Choose appropriate data types, setting the maximum field size to something more reasonable than maximum 255 characters. So, again, if I were doing this, I would have a role table, and I would use a foreign key from the role table to stand in for, we'll have a primary key named role. Okay, never mind. So why not just call it the role table? You would call it the role table, and you would have a role ID, and then you would have just the name for the role would be the second column. I do not like this. This is we'll consider what data needs to be added to this table for now. I'll leave just so in my opinion, and I didn't make this lab, in my opinion, just off the top of my head, we haven't done the design for this. What we really need to do is the business rules and then the data modeling. Then we create the table. So we kind of skipped all those things. So you're assuming somebody else did it, right? In my opinion, from what it looks like it's doing, this table should be called role. Then you would have a primary key called role ID. And then you would have role title or role description or role name. So the role name would be technician, the role name would be user, and that would be role ID number 1 would be technician, for example. Instead, it's trying to seem like it's adding security to it, and the security's it's all messed up in my opinion. But we're going to go ahead and do it how it says to do it. Maybe I need to rewrite these labs in the future. So again, create a new table named security. There might be a reason for doing it this way. Who knows? Named security using the table design tool. So let's go find that. I had a big, long lecture that was unimportant, and I'm redoing it. Also because there was a slight difference from the instructions here that I wanted to redo anyway. So the table, creating the table, you go to create, go to table design, double click on that. And this is going to open up a new thing to create a table, right? If you have any of the other tabs open, by the way, tables, just close them and say yes to save your changes if you haven't already. So the name of the field, again, against what I think it should be called, is just called role. It's data type short text. 255 is too big. Let's make it 20 instead. That's about as big. The guide for the reasonable thing is like how big are these things? Then like add buffer in case you have new roles that you expect to add maybe later on, but like what's a reasonable length of letters for that role? Maybe more than 20. I'm going to say let's do 30. 30's definitely got to be long enough. And again, this is not how I would actually do this. I would do a little different design, but we're just going to do what the instructions say. So, and then right click on this row and pick primary key, and that will make it the primary key. Then click this just to exit, and it'll ask if you want to save it, and you'll say yes, and then you can change the name. This is where you name it security. I'm sure there's another way you can do this, the other way around, but to me, that's the easiest. That way I know I've got the table the way I want it. I'm ready to name it. So I'll name it security. Notice I didn't name it TBL security because it didn't tell me to. So follow the instructions, though. If you wanted to be consistent with the rest of the database, you would call it TBL security. So whatever. Anyway, and we're not adding any data to it. If we wanted to add data to it, we just double click and add a role, right? Does it say to... saying for example, but we're going to leave it empty for now. So in our discussion of relational databases, we talked about how tables are joined together by fields with similar types. This is the primary key, foreign key. At first I was like, I can't leave this in here because we didn't talk about this, but I have talked about it in videos. So normally this is like, hey, we talked about this in class, right? But anyway, you get the idea. To make our connections, we link primary keys to foreign keys of related tables. It's necessary to create queries and reports that display complete information about the entities in our system. What this means is your data about your different entities, the values of the attributes, like the name of this doctor versus the name of this patient and what is this patient being treated, whatever. All that data is going to be spread out because of the way relational databases work to eliminate all those anomalies that we talked about in another video from last week. I remember doing the video. To eliminate those anomalies, we spread things out over several tables. So sometimes when we want to get the information back together again, we have to know how the tables are related, and that's accomplished by knowing how the foreign keys and the primary keys connect those tables back up together. So there. This is necessary to create queries. Okay, where am I at? Use the database tools tab, relationships icon to review the connections between any two tables, right? Among all the tables in our current hardware tracking system. Between literally means having to do with two, right? So between technically means two things in a connection. Something that exists beside one and beside the other halfway. Well, I can't say it without saying between. That's what I'm trying to do, but I can't do it. Something interposed. Two entities. There's a word. There's a word besides between. I can't think of it. But among is what you use for more than two. So whatever. Among us. What was I going to do? Oh yeah, database tools and then relationships. This is kind of like a simple schema. It's kind of similar to an ER diagram. It's not an ER diagram, but it's like one. So let's briefly, I think we did this in a previous lab, but I'll review if we haven't reviewed this yet. So one employee can be assigned many pieces of hardware. So a piece of hardware can be assigned to one employee. Each record in this table has at most one employee assigned to it in the assigned to field. But an employee might have his primary key, let's say employee number 2, could be in the assigned to field of several rows because that employee has been assigned more than one piece of hardware. A piece of hardware could exist along with a one. Okay, this is the way you say this. It's not making sense. So let's say what this is again. This is obviously a junction table because you've got the one side here, two minis touching it like that. It used to be that this was going over here to mini and this was going all the way over here to mini, but you can't have that actually in a database management system that's relational. You can have it in your ER diagram, but you can't have it actually in the database system. You can only, anytime you have many to many between two things, you have to convert it into two one to minis with a new bridging table between. So what this means, what this represents is all the software that's installed on all the hardware. So one piece of software could be installed, like every one of these has Outlook on it. Every row in this table, well, every piece of hardware that's represented by every row in this table might have, say, Outlook installed on it. Every piece of hardware could have several different pieces of these software installed on. So this one, say hardware number 7 has Outlook and Access, and also what's another piece? SQL Developer, like I was showing before, and so on. So like one going to have 3 of these things, one could have 0, one could have 10. So that's a many-to-many relationship. So the contents of this table represent any combination of these. Shows it should be unique. So say hardware number 1 has software number 1, whatever that is. So let's say hardware number 1 is like an AMD 7th generation, whatever, with Windows 7, and software number 1 is Outlook. So there will be one row in the config table, TBL config, that says 1 and 1. You combine those two together and it makes a primary, think of it as 11. There will be only one row that's 11 in the database. If you put software number 12 on hardware number 5, there will be one row in the entire config table that looks like 512. It's not really 512, it's 5 and 12 combined together for a primary key, but I'm calling it because it looks like 5. There will only be one row that has 5 and 1, 2 in it. That's what that is. So that's what this thing means. It's just describing how all these things relate to each other, primary key wise and everything. Let's pause and see what the rest of it's asking for. Okay, now I see we're doing joins. So number 8. So the reason why we looked at that relation, let me go back. The reason why we're looking at this is because whenever you're making joins, especially join queries, which means you need some data from this one and some from this one and so on, you need to know how they're related. You need to have a picture in your mind of which thing's the one side, which side's the many side, which one's the foreign key, etc., what the foreign key is, what the name of it is, etc. So that's the reason why we're looking at this. If you get used to a set of tables that you work with in a database all the time and you're the person writing the queries, then you don't always need to have the map in front of you, but it's a good starting place, especially one this small. I know in my mind, I think I could probably write queries for the thing I probably want to look up is the column names, it depends on what your interface is. Sometimes it'll do the autocomplete for you and then you don't really need it. But in any case, you want like some kind of picture of how everything's related because you need to know this picture on some level in order to write join queries, which is what we're about to do. So the next we will create... See, they have this here because technically, grammatically, you should have a comma. And I'm not sure I would do it either, but I didn't write this one originally. So next, we will create a group of advanced queries. If you're not familiar with creating advanced queries and Access, the following help topic. So you can look this stuff up, right? I'm going to kind of help show it to you, and I'll have to remember how to do it. I know how to write joins in SQL. Access has got to be make it hard on you though. So we'll see if I pull my hair out or not. So use the query wizard or the query design view to set up and run queries as specified below. So display a list of hardware by employee. Display the full employee name. Okay, let's go back and forth here. So display the full employee name. So what you need to know from this is first name and last name, which order you're going to put it, but you need to know this. You need to know that the name fields are called F name and L name. That's why we're looking at this. Likewise, next, what? That didn't make any sense, but whatever. Where am I at here? So next, yeah, okay. Here, display the full employee name, hardware manufacturer. So again, the reason why we need to know this is because the hardware manufacturer is all the way over here in this table, and it's called manufacturer. So we're good there. I don't think I need this anymore. If I do, I'll come back to it. That is 2. There we go. The manufacturer, the model current value, you just kind of want to, and then this is Oxford comma. I think apparently Word likes Oxford commas. I do too, but so display the full employee name, the hardware manufacturer, model current value, and the operating system. Sort the output alphabetically by employee name. Save the query using the name hardware by employee. So let me set this up and get back with you. All right, it's this simple, except before I started the video, right when it was running, I'm like, it's starting counting down the startup. I'm like, I forgot to do the order by part. But anyway, I'll do that as we go. So this is all you do. You pull over, so like this, right? You pull over and drop the tables involved in the query. So you need to know the first name and last name from the employee, the employed. You need to know that person's first and last name. And you need to know several things from the hardware table. You need to know manufacturer, model, current value, OPSIS, maybe something else. I think that's it. Anyway, whatever I got here, let's see what it says. Current manufacturer, model, current value, operating system. So I think I've got everything. So what you do So you pull those over, and then you go make sure it's on select over here, not one of these other ones. Go down to the bottom, and the best thing to do is to start, just like if you were writing a SQL query, it's usually often best to start with from table name and then build the rest of the query. Same thing here. Pick the tables involved. So I need the first name, the last name for the employee. So I do the employee table first and the table row. And then up here, I can pick which thing. It limits it to just the things in that table. Again, that's the reason why we pick the table first. Then we can go up here. So if you don't pick the table first, let's say, pretend we're going to do something else. It could be any number. Yeah, look all three of them. But if you wanted to, like, say one more thing from the hardware table, you would pick the hardware table first, and then that's just the hardware table right there. The image stuff at the bottom, that it's weird, so it's got more stuff. But you can see there. So if we wanted to add the RAM or whatever. If you want to make sure it shows up in the result, make sure you click the checkbox. When you think your query is correct, what you do is click run over here, and it shows it. This is like a test run. This is not saved yet. So you see, again, we might need to do the order by, because I think I left that out, but just make sure first name, last name, manufacturer. If you want to spread it out, do that. Double click on the line there. It looks like we got everything. We don't have, I think maybe you're supposed to have values here. I didn't look them up, so there's nothing for mine, but yours maybe should have some values, so don't freak out if yours isn't empty too. Other than that, I think the only thing left that I didn't do was to order them. Sort the alphabetically by employee name. So I want to do last name first and then first name. So I'm going to go back to the design view and go down here to where it says sort, and I'm going to pick ascending by last name and ascending by first name. Let's see how it does it, because I think it's going to do first name. It's going to do the order that they're in, which is aggravating about Access, because there's probably, yes, by first name. If you do it this way, I'm fine with it. To change it around, I think what you have to do is actually, hold on, let me show you the right way to do this. I think I just remembered in design view. I kind of hate design view, but what? Either an object bound then to open the tables, read write. What? Oh, I don't want to open the table. No. I want to open. I just want to do the query in design view. That's what I want. Okay. I think the way you do this is like you just go, you get rid of this. Not sorted. So don't do this. Just go over here and pick employee and employee. Those tables, pick the first name again. This time I'm going to pick the last name first and then the first name last. Then I'm going to sort by ascending here. I think this is how you do it. And I think that's really kludgy, honestly, but we can see if it works, and it does. So that's one way to do it. The way I would do it is I would just write the SQL query, except it wouldn't be this messy, because I wouldn't have to use all the square brackets and stuff if it has any. I don't see any right away, but for current value, because it's got a space in it, you have to use the square brackets. I don't know if you guys can read this, but the SQL query, which you don't have to know yet, is, from all the things that you want. Select all the things you want from the table employee inner join hardware table on the employee table primary key EID is equal to the table hardware category, column called assigned to, and then order by last name, comma, first name. So there's a lot more to it. It's telling which tables they're from, and TBL hardware dot assigned to and all that, the long name for it. But that's how a SQL query would look. That's how I would do this. I hate doing this design view stuff, especially when you have to do like this kludgy thing over here, and it says a show. Actually shouldn't show it. So I don't even know if it was showing it before, but it shouldn't show it. Yeah. And it still should do it. Yeah. So it does show these two in this order, but it sorts in the other order, which is whatever. But anyway, once you think you're done with that, you would close it and say, oh yeah, I want to save it. And then you look and see what the name's supposed to be. Hardware by employee. There we go. And this mic is down on my keyboard with the cable. Hardware by employee. Technically, Prepositions should be lowercase in a title. Is that what's we got here? Yeah, that's the right thing. So, okay. Now, whenever you want to know what the hardware by employees, so what is this telling? What's the information? Let's come back to that, because I don't think the Access Lab 3 write-up says this. What's the information? It's telling you, very short nutshell, it's telling you what computers are assigned to which people. So what you should notice, if this is a good example, and it might not be, but we'll see, you should have some people in here more than once. Good, good. So this guy's got 2 pieces of hardware assigned to him, because it's employee to many side hardware. So he could have both an IBM and a gateway. All right, that's fine. Agnes has a couple of things. You could have Rick Jacober could have 10 things if you so desire to assign them to him. That's possible. But any one particular piece of hardware, and we don't do hardware ID, so we can't see this because a lot of things have the same values in the rest of the table, right? But if you look at the hardware IDs, each hardware ID would only appear in here once. Just to prove that, let's do it. Don't do this in your lab. I'm just going to add it to show you. I'm going to add one more field from the hardware table. I'm going to add the HID. It's showing. This should show up in here somewhere. Let's see. So you see, whatever you see over here, it should only show up once, because you can't. It's not glitching the matrix where there's more than one. You're like, your laptop doesn't duplicate and then you assign one duplicate to one person, one to the other. You know what I'm saying? So your hardware IDs for each of these people should appear once. Oh, does it really make sense? But yeah, that's, now I have to like pause and think about that. Hold on. Yeah, that makes sense. Has to make sense. Yeah, it makes sense. This stuff's not always intuitive, even when we work with it all the time. But let's put this back. Yours shouldn't have this, and mine shouldn't either. So I'm going to just get. I think the easiest way to do this is make sure your cursor's over here and click delete column, and that should fix it. So save, yes, and go on to the next step. All right, so let's read this. Display a list of all software installed on each piece of hardware. So this is a many-to-many relationship. This is going to, here's the thing that's not obvious right at first, and I forget how Access handles it, but if I remember correctly, in my mind, Access is supposed to be user-friendly, and you don't have to understand how relational databases work in detail in order to operate with them. You just have to follow some guides about entering data, how to make a query, blah, 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 and it should work for you. So, in my opinion, a proper design of Access would have been such that you would not have to know that the config table had to go in there. You could just pick the hardware in the software table and say the things you want, and it would figure it out. It's like, it would say, hey, this has got a bridge table in between. That's how we work it in a relational database, and we'll figure this out and do it for the user, instead of the user knowing that he has to put that table in as well into the query. So, if I remember correctly, from doing this before, you do have to put all 3 in yourself, because you have to sort of know that that thing joins the 2 many-to-manys together. But anyway, so it's a list of what is it? Display software. So you need to know what each one, the last name of the person to whom so it's actually 4 tables, because you got to have the employee's names in there too. So think about it. Display a list of all software installed. You know you need the software names, because that's the information. We don't care about primary keys, because that's just gibberish. We want the software names. Those exist only in the software table. On each piece of hardware, we want to know something about which piece of hardware. We don't want to just know the primary key, HID 123.7.15, whatever. We don't care. We want to see, like, it's a Dell Inspiron desktop or whatever. We need the hardware table. Display the hardware serial number, operating system. So all that stuff's hardware. Software publisher, that's all software. Sort the output numerically by hardware serial number. Save the query name using the name installed software. So I think I must have jumped around and saw something about employee. So we're not involving the employee. So it's really just confined to those 2 tables, the hardware and the software table. But again, in order to make this work, you have to include the config table. So let me set it up and show you how it's supposed to look. And just in case I skipped this last time, which I think I might have, you want to go to create, query design. It opens up this field that you build the query in, and then you put in the tables involved. So the tables involved in this one are software was mentioned first, so I'll put it first. Hardware was also mentioned. Notice there's no connection between them. Why? Because this is what connects them. And I'm almost 100% positive that you have to put this in here to build the query, so I'm just going to go ahead and do it. I'm not going to like do the wrong thing first and then find out it doesn't work. So you need all three of these things in here. And I'm just going to show you the start, and then I'll pause and finish it. So I know I need stuff from the software. Let me just count them. Display software, display the hardware. Where's the software? So the software. So it is the person. It does need the employee. The last name of the person to whom the so we do need the employee table too. Sorry, I know I thought I saw it in there, then I didn't, and then I saw it again. So as far as software goes, we need 1, 2, 3 things from it. So let me go back here real quick. Pull the employee table in too, because we want to know that. So you can do a query across all these. That's fine. That's fine. But we know we need. Did I say 3? See, I've already forgotten. 1, 2. It looks like 3 things. So it might be easiest just to do this: software, 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 and then start doing the things. So the one I know one of them was vendor. What's this one again? This is why you want 2 screens. Software display. The software's in the middle. That's why it annoys me, because it mentions it first, then it does the hardware, then it does the software last. So whatever. Publisher, title, vendor. I can remember that, right? Publisher, title, vendor. Publisher, title. So the name of the software, like Outlook, and then who does, like Microsoft does Outlook, right? Vendor. There's no vendor site, so vendor site. I mean, there's no vendor, so vendor site. Okay, I'm going to finish the rest of it and pause so you don't have to watch me do this. Okay, there is a bit of a snag with this. I was trying to make sure it's correct, and I noticed some problems. So here's what I'm going to do. I'm going to show you what the problem is and why it's happening. So I'm going to create a new query, and there's really nothing wrong with it. It's just confusing at first. You know, it's because Access hides so much from you. I'm like, what's going on? It's better if I write the query myself, honestly, but it's not the best SQL editing view either, so whatever. So what I want to do is make sure that these tables are on the so we're going to have the employee in there somewhere. We're going to have the software table in here somewhere. We're going to have the hardware table in here somewhere. So that's connected to that. And then in between these two, we should have the config table. So this table allows us to know what software is installed on what hardware, and these 2 tables let us know which employees assign which hardware. So there's relationships among all these things. So I want to start just to show you. Here's the thing: if you write the query that you need to write, you'll end up with 34 results. And in my mind, if you think about it, if you look at the size of the config table, there are 39 entries there. So you should have 39 pieces of software installed on maybe not 39 machines, but there will be 39 installations of software across the hardware. There will be 39 installations of software among the 22 computers, whatever, how many you got in your table, hardware table. Among those computers, some subset of those, maybe all 22, maybe like 15 of them, have some software installed on them that's in the database. But the config table lets us know that there are 39 instances of installation. So our results should show the serial number, the manufacturer of the hardware, the publisher, whatever manufacturer of the hardware, whatever it is, and then like which piece of hardware has got installations on it. It'll tell us who is assigned that hardware. But there still should be 39 entries because it's all about the software installed on the hardware. But if you actually write the whole query out, you'll probably get something like 34, and it's probably because there's some nulls somewhere. In order to get every instance, you would have to have, and I haven't verified, I'd have to go look and see exactly how, because the way it makes the query is really weird. But I'd have to go look and confirm it. But so don't worry about it. If you get 34, it's probably right. Anyway, so what I'm going to show you is if you make the query at least with the two things. So in this case, this has to be in here in order for the query to work, but you don't actually have to put it down here. So if you say from the software table, I want the title of the software, and from the hardware table, let's just do the, instead of the HID, make it somewhat sensible, we'll do the serial number. So there we go. And if you just run this query, which is not the finished query, right, but it's a query you could run, and here's what really irritates me. Now I have to go to create and pick query design, and it'll create a new query, but I need to be here so I can do run. I don't know, there's probably a shortcut or something, but whatever. So if you count this up, you see you've only got 34. Hold on. Okay, it's such a headache. So in the example I did before I made the video, I did, let me see if I can do this. Remove table. I didn't have the employee table. That's where the problem is, and I'll show you why here in a second. If you take the employee table out and run this again, you shouldn't have 34. No, don't save it yet, because we're still building it. Now I have to go to create. Is there a way to run this? Run. You should be able to run it right here. Run. Whatever. I hate this stuff. Bad interface design. And again, you might know how to do it. There's probably some way to do it that I don't know, but I should not have a problem finding out how to do it. It's my point about interface design. Anyway, create, go to create. Now I have to be over here to get what I want, which is this thing right here, but I don't want a new query. So bad. God, I hate this stuff. So now I have 39 results because I took the employee table out. The employee table out is the problem, and I'll show you why. If you go look at the employee table, it still doesn't quite add up. There's probably one missing somewhere else in the hardware or something too. But if you look at the employee table, let's double click on it. Not the employee, I'm sorry, it is the hardware table. Oh, so frustrating. Keep track of all this. 1, 2, 3, at least 3 nulls. There's not one lurking down here, I don't think. That's just a total table, total of the current value. So at least 3 things are missing here. These are nulls. So if you add, here's what happens. If you add this table to the query, the employee table, so let me go back to design view. If I drag this over, let me show you this. If you go to SQL view, you can see where it says software table, inner join, hardware table, inner join, config on table hardware equals table config on table software. And this is not how I'd write this. This syntax would look different if I wrote it. But you see how there's no employee table here. And it's kind of like nested and stuff. I don't know what's going on there, but whatever. That's not how I would write it. But if you go to design view and pull the employee table over and you're saying, I'm going to use this in the query now too. So you add it to the query. Before you even pick what you want from it down here, it's still going to set up the join for you. So if you look at the join SQL view, you can see employee tables here now. And here's the thing, with an inner join, if anything's null, that row will be ignored from the results. So even though you have hardware installed on all the computers, because of the fact that the employee table is in the join in the query, and because of the fact that some of the hardware is not assigned to any employees, if you do this whole join across all these tables, those unassigned hardware have nothing for assigned to, no employees are assigned to them, will make you have fewer results. You would have to use what's called a left outer join or a right outer join or a full outer join in order to get those included. And we're not going to go over how to do that yet because it's an advanced topic. Unless it's later in this lab. Watch it be later in this lab. But anyway, so we're leaving that out. And the whole reason I'm telling you this is if you finish this whole query, you'll get fewer results than you expect. You're like, I thought there were 39 installations in the config table, and there are. But you don't get to see all of them because of that employee not being assigned, just because of the nature of how this is done. And it's not like databases and relational databases can't do this. It's just access makes it awkward, and it's beyond the topic of the curriculum right now to show you in this lesson how you fix it. And it's not even a big fix. You just have, you know what you need? You need MySQL or SQL Developer, Oracle or Microsoft SQL Server or some The more I use Access, the more I hate it. But whatever. The whole like making it easier for you gets in your way if you know what to do is my whole point of it. But it's a fine database for, again, a small business if you're not a database expert. And I'm not even a database expert, not a super guru, but I know enough that this annoys me. But anyway. All right, to finish this up, I'm going to pause and show you what you should have in the end. All right, when you're done, these are results. So you have 34. And again, it's because if any of these columns, right, there's one thing you get from the employee table, and that's the assigned to value, which, the assigned to value is the foreign key that's null. But there's one thing you get from the employee table, which is the last name. But you can't get the last name of somebody who doesn't exist, right? So because of the way inner joins work, you can't have any nulls involved when there's foreign keys and primary key relationships. So all those assigned tos that have null means you can't even have a record. You can't have a row for that person where there's no assignment. Even though software is installed on that computer, it's installed on a computer to whom the computer is not assigned to anyone. That did not make grammatical sense. The computers which are assigned to no one have software on them, but they don't appear in the results because you can't have nothing right here in this because of the way this works. Because the person who asked for this query insisted that there be their last name here. And again, you can probably do a left outer join, right outer join, whichever the order the tables were added to get this included. I might see if I can do it after this, but I just want to show you what the query should look like. So it should look like this in the WYSIWYG view. So you should have table hardware, table employee, software, and then the things you're including. If I'm not mistaken, and even if I'm one off, you can be one off. You don't really need every single thing, but display hardware, serial number, operating system. So I got those two: last name, the publisher, the title, and the URL. So it looks like I got all those, and then you sort in ascending order it better be ascending order. Why would you not do ascending order? Numerically it's ascending. So pick ascending under sort for serial number, and that's the query. Close it, say yes, and what's it called? Installed software. Yeah. Did it go away? Oh, no, it's here. Installed software. Now, let me close all these things that are annoying here. If you double click on installed software, it should show you all this stuff. So I'm going to pause this and see if I can fix it and show you how you fix it. But this is not wrong. If this is what you've got, turn this in. This is right. What I just showed you, again, might want to pause on it. That's another thing, a tip. I'm sure you know the tip, but you pause and make yours look like this, right? You just drag these tables over and make these things look like this, and it's done. Let me see if I can fix it real quick. All right, here's the fix. It's still, it took a second to find it, but if I go to design view, the way you make this work is you double click on this line that symbolizes the joining between the hardware and employee table, double click on it, and then pick this last option, include all records from the hardware table and only those records from the employee table where the join fields are equal. So you'll definitely have everything from the hardware table, but some of the employee, and it will only include the employees if it's equal to the hardware assigned to. But for the ones where the hardware table doesn't have an equal in the employees, it will also show it, which is the nulls for assigned to. So let me show you how this works. When you run it, if we run this, you should get 39 records now. And here's what I was talking about before. See how they don't have values here? There's 5 of them. There were 34 results before. So because some of the hardware has more than one software installed on it, those particular ones that had no employee assigned to them, you would get a hit. They would have been left out for every time a piece of software was installed on a piece of hardware where the employee wasn't assigned. So apparently there were 5 times that software was installed on a computer that did not have an employee assigned to it. So 34 plus 5 equals 9. The 5 times are the ones where the employee's empty here. Does this make sense to you guys? I would not be surprised if it didn't. But if you looked at the hardware of these, you might see this might be the Jacobson twice, right? And then Agnes twice, and then one person had a piece of software, whatever. I think you get the idea. So the config table is 39 long, so there should be 35 records here, but you're only going to get that if you make that adjustment. So whichever one you turn in is fine. If you want to do the outer join thing that I just showed you how to do, and again, the way you do that, and I don't probably you can rewind, right? But you know, like okay, rewind, or I'm going to go and show it to you, which is right here. So you double click on this thing and then pick that number 3. If you set it up the same way I did, in the same order. If you didn't set it up in the same order, you might not get the right answer. So it had to be in this order, the order that I showed you. All right, let's pause and read the next question. All right, this next one should be easier in a way, but hard. The hard part is I have to remember how to do aggregate queries at the design view in Access. I could write the SQL query real fast. It's a much simpler query. But let me explain what's going on. So a totals query, aggregate functions work this way. Let's say what is the cost here? I mean the cost, the column that we're going to do, the sum and average current value. So it's current value is what I thought it would be. So the current value of the table, I need to go populate some data in there. I'll do that in a minute. I'll make up some data in between when I pause. So you should have values for your computers, right? Like $1,000, $800, whatever the computer's worth. What these queries do allow you to do things like totals. So you can write a query that says something like select sum current value from hardware, and that will show you one result. It'll be one column wide, one row deep. It'll have, in other words, it will have one value, and that would be the sum of that current value column. And then you can do average. What's the average cost of your computers, right? That will give you one number. It will give you a table result of one row, one column, and one row. In other words, one value, one field. And in that field will be the average of all the. So you can do, that's what aggregate functions are. You can like sum up a column, or think of spreadsheets where you sum up things. But so we're going to follow directions here to see how to do that. We're on the last page, so I know it's an hour and a half. Again, watch this in chunks. Do it on your own, and then see if you did it right by watching the video. Put this in the background if you've got yours done. Rewind, fast forward over my rants and my explanations if you need to. I recommend you listen to every word, but I know that you probably don't need to listen to every single word. But you do want to get like the gist of the whole video, though. All right, so display the sum and average of the current. So that's what our task is. And what I'm going to do is pause, stop wasting your time. I hope, set it up, and show you like probably one at a time, D and then E. All right, so this is how I did it. I just pull this hardware table over, so the hardware table is in our query. Again, this is query, right? You go up to create, query design. Throw this table on, and really all I did is go down here. You might need to click that. Not sure how that figures in, honestly, because all I do is I make sure that I go down and pick the hardware table for all these. Pick category first, because we're going to do this grouped by, and it's something hard to explain how that works and what that means in SQL. But basically, you can take these if you have aggregate functions like sum and average and stuff, you can group those things by different fields. So in this case, we're just going to do it by category. You could do it like by region of sale. Like what's the average amount of sales? Or let's just do sum. Let's do the sum of all the sales in the East region, the South region, and the West region. Imagine you have a table that has regions in it, East, West, South. That's one of the columns, right? And then you have sales. And there's a sale, like an amount for each sale, for each time somebody sells something. That's a record, right? You can get the average of all the sales, the sum of all the sales for the whole table, but then you might also want to break down by like a region or something. In this case, we want to break down by category. If we leave this column, let me just show you. If we leave this column out, I'm going to delete columns. As a matter of fact, let me just do the whole thing from the beginning so you can see how to do this. Let's just close this. No. And I'm going to do a new query. So I will go to create query design, pull the hardware table on. You might need to click, I think you might need to click that actually to get the things that you need. So click that, go down to table, pick hardware, and what I'm going to do first is I'm going to do the field current value. Take the group by out for now. I don't know why it does that automatically. That's not what, actually don't take it out, just change it to sum. Same thing here, current value. Current value, which one is it? There it is. And then instead of group by, do, see if you have this up, it automatically sets these things to come up for you, these aggregate things. So just do average instead. So then if you run this, this is what you get. This is what I was saying before. You have one column and one row. In this case, you have two columns because you picked average and sum. If you just did sum, you would have one column and one row. If you picked just average, you would have one column and one row. But we picked both. We want the sum and the average of the whole table. So this is across all categories. But if we wanted to change the query to do what it asks for in the assignment, then what we can do, and there's probably a way, and I don't know what it is, to move these insert, yeah, it's the insert column. It'll do it. Insert one right there. There we go. There we go. We want to break this down by category. So what we do is add the category, and then make sure group by shows up here. And this is saying I want to do the sum and the average, but I want to group by the category. So when you run this, you can see laptops. There's sum of all the desktops and the average cost of a laptop. God, it's desktop. Here's the sum of all the laptops and the average cost of a laptop. So let me say that one more time. Here's the sum value of all the desktops. Here is the average value of all the desktops. Here is the sum of all the laptops, and here's the sum of, oh God, the average of all the laptops. It's late. It's late. I had something else to do on Sunday, and I'm like, I'm going to stay up late and get this knocked out before Monday starts. Now I have to do a lecture video for another class tomorrow, but at least you guys won't be late, so you're welcome. So what is this called? We save this by totals query. Is that what we call it? No. Create a totals query that's named hardware asset replacement cost by category. So the idea is one row resulting data sheet for each category. One row per category. There's laptops and desktops. As far as I know, there's only two categories I have in mind. You might have more, and you probably have different values, so that's fine. I copied and pasted that here so I can save it like that. Now, again, for all these queries that you save, you can just double click on them whenever you need it. Is this installed software? Sure, I'll change mine. Mine's going to be different from yours now. That's all right. So there's that one. I want to pause and get. I cut myself off, but I did that, but I don't care. So I'm going to create a new query, and in this particular, I don't need these properties or any of this stuff. I guess I could have used that to add tables, but I can just add tables this way, right? So this is a, let's see what it is. It might involve more than one table. I'm not sure yet. And of course it won't. It just like expand and so, create a, that uses category of hardware, manufacturer of hardware, model of hardware, current value of hardware. This is all hardware. So put the hardware table in. And don't think you need anything special up here. All you need to do is add those. So this is all hardware, right? That's the only option here. And then the field is going to be category. And by the way, again, the check mark down here is whether or not it shows up in the query or not. You don't always have them showing if you use them in the query. But most of the time, by default, you will. So category manufacturer, which means done by hand, literally. Just that's some more etymology for you. Model, made by hand. Facere and manus. Manus means hand in Latin. The plural is manus. It's feminine. That's why it's la mano in Spanish, because it's originally U.S. ending but feminine, so la mano, la main in French. think it's really interesting. So manus. My Latin pronunciation is not perfect, but I know it's a longer U-S on the plural. Apparatus. Apparatus and apparatus. We have a lot of apparatus for dealing with this. It's the plural. The plural and the singular are sort of the same, except the vowel's longer in actual Roman speak, but whatever. That's another tangent. So model, current value. Current has to do with running. Something that runs. And then current value again. And here's the thing. I'm not sure how to put the times point. Can I do it right here? Times 0.15 would be less. That's the math you need to do here. This is how you would do it in the SQL query. Let's see if it accepts it. It does not. So let me review how to do this. All right, so it's almost that simple. Here's what you do for the new column that you want to be a derived column. This is how you do it, and we redo this from the beginning. You type what you want the name for it to be. I want to call it future value. So future value colon. The colon's important. That's how you signify that this is a calculated value. Because current value has a space in it, use a square bracket. This is next to the letter P on your keyboard if you're using QWERTY. So current value, close it, the right square bracket, then subtract current value, again in the brackets, times 0.15. Right, it's not just times 0.15 because that's a small number. It's you take the current value and you subtract 15% of that value to get the future value. Then you hit, and here's the only, and I'm not going to ask you to fix this. There's a way to fix it, and I can't remember what it is. Maybe you can do it right here somehow. But the only problem with this is it won't be formatted as money, because in the original table, hardware table, you set this data type to currency or whatever. And in the query, there's no obvious way to do that. I think there's a way to set it up in the query. I'm not going to ask you to do it. I'm not going to ask me to figure out how to do it and show you, because the assignment doesn't ask you to do it either. So it just says to calculate the value. Create a query, derive column, display the category manufacturer value. New calculate shows is 50% lower than the current value, so it's 50% loss. Yeah, depreciation. Save this query. Doesn't say anything about formatting it as money, so I'm not going to care about it. So so I'm just going to save this exiting, and then I'm going to get that name, hardware depreciation. By the way, there's a lot of, it's not depreciation. Depreciation is it? It's depreciation. It's species, not species. Just a tip. If you say species, you sound very precious. It's precious special species. So it drives me up the wall. And here's another one. Just like this is like a gift for the end. I'd have to show you how to do the backup thing here in a second though. But processes. We have a lot of processes to deal with this. It's not processes. That is incorrect. That is not right. You will only hear people from like Harvard and Princeton saying it, but they're saying it incorrectly. The plural in English of process is processes. Now you can go to Canadians and they say process instead. That's fine, whatever. But it's not processes. And it comes from the Latin thing again. Processus, processus. The plural's long, but it's not. It doesn't really come from Latin because the word in English is process, and the regular plural for a word in English is just "us" at the end. Processes. You don't say processes. So annoying when I hear somebody do that. It drives me crazy. And it's only hooty toot smart people who do it, and that's what makes it even more ironic. I mean, it's ironic, but it makes it even more annoying. It's kind of like, what's her name? Andrea Mitchell correcting Ted Cruz with the whole Faulkner Sound and the Fury thing. Oh, it's exactly like that when somebody says processes to me, or in my earshot. Anyway, look at what I was talking about. Andrea Mitchell, Sound and the Fury, in case you're curious. It's hilarious. All right. what would so answer these questions. I'm not going to answer these for you. You can answer them, and then file save as backup database, and then that's what you upload. So I'm just going to do that to show you what you should be uploading. So file save as save database as, and it's got to be one of these, and I haven't done it in a million years. So let's see which one's right. Backup database. There it is. Backup database. Click that so it's selected. It's not the most user-friendly display to me. Like, okay, I see. Now this one's gray. Okay, whatever. Save as. You can have the same name here, I guess. So click save. And it looks like it adds some extra numbers or something to differentiate it from the one you started with. So I'm just going to close this and double check it in the C:. Does this work? Backslash. I don't think I've ever done this, but I'm trying to get directly to the folder so I don't have to like show you my whole system. So, okay, here, I should do that more often now. Okay, so if you look here, it's this one, the one that you just created, right? So if it went in doubt, well, actually I just saved on this one too because I saved the query and stuff, but it's this longer one that you need to upload to the Dropbox. And that's what I'm going to look at this. After closing all versions of your Lab 3 database, upload the backup. So, yeah, go ahead and, I think, I'm exited out of mine. Upload the backup version to the course assignment submission folder by the due date. So it might not be open. Yeah, I have to make sure. But after I do this, I'm going to upload this document, which I think is correct now, the Word document. And I'll put this video with it so you guys can get started. If it gives you an error message, because send me an email message if that ever happens. I think it's been expanded since the time that the person who wrote this had that problem, so it shouldn't be a problem. And then you take the Access Lab 3 quiz. That's the end. This is 45 minutes, almost 46 after the hour, so an hour 46. And I won't give you any more etymology lessons. I'm sorry for doing that, but anyway, I'm not really. Take care.